Sam back again, and in this part we're going to look at the 3 hydrology rasters and render them in ProRaster. So I've got ProRaster running here. I've already added those rasters in as raster sources. So let's go ahead and create a lookup table algorithm. I want to display the, the drainage area data. So we don't want hill shading on that. We'll turn the intensity off. Go to the color layer, choose the raster source. Here's our Upstream Drainage Area. And we've got something displayed. First thing I want to show you is the histogram for this raster data set. So you can look at the histogram through the data transform editor. Just add something in, doesn't matter what it is. Go to the raster page, and if I go to, say, the merit DEM, and we look at the histogram of the merit DEM, you can see this graph. You have a fairly normal histogram. It's skewed, but a fairly normal distribution, which you might expect from terrain. Now if we go to the upstream area, drainage area distribution, here's the histogram for that. And you see it's not a normal histogram at all. It's highly skewed. All the information is right down here. And if we go to the spreadsheet, have here a look at the cumulative percentage, 0 to 100. So look at about 90%. Is here. So we get to 90% at about 157 square kilometers, but the data set itself then runs out to 5.9 million square kilometers, which is probably the Amazon, I suppose. A very, very highly skewed histogram. So that's going to make things a little bit tricky to render. And the first thing that I want to show you is the difference between an equal area transform and a stable equal area transform. So let's go equal area. So equal area uses the histogram to assign an equal area to each color in the raster. So if we zoom in here, you can see once we zoom in, all that blue resolves itself into individual creeks and rivers. You see the rivers in red here. Now, I just want to look at this using nearest neighbor interpolation, because all of these creeks and rivers are only a pixel wide, so we don't want any interpolation. So there's equal area. You can see that these are all just mainly solid blue. If we go to the stable equal area, then it all suddenly resolves and you get blue and a gradation right through to red. Now that's because the stable equal area transform uses the cumulative histogram that's created in MapInfo ProRaster. And that histogram is much better for data that has statistical outliers or data that is very highly skewed. It does a much better job of building a transform. It's a little bit slower when you go to render. And normally you'll see no difference between equal area and stable equal area, but in an example like this where you have very strange histogram, you see a big difference. So, so there's our raster. That's not very good. Not very happy with that. We probably need to change, let's change the color table, maybe to Viridis. And I just want to perhaps come into here, change it to maybe a logarithmic transform. Yeah, so now you're starting to see the major rivers highlighted. So we can see the Amazon and we can see some of the tributaries, but everything else is sort of blending out. So we'll come back to that. So now I want to put some global imagery underneath this so that we can see something underneath. So I'll add an image layer. And we'll just move this one down so it's underneath. And then I'm going to choose the blue marble imagery. So for the time being, we'll turn off our drainage. So here's our blue marble imagery. This stuff actually has events in it. So it has an image for each month of the year. And at the moment, we're looking at, say, January. So this is northern winter, plenty of snow. But you can cycle through these, and as we go through the months, you'll see we'll go into summer and then back into winter again. So let's go into northern hemisphere summer, say August, getting plenty of green. Now I want to drape this on some terrain, so let's turn on intensity. This is our hill shading. I'll choose Merit DEM. So there's so now we're seeing the imagery clipped to the DEM. That's the default. You can change that if you want. Let's just do some adjustments. I think this shadow needs a little bit of adjustment, so let's take this over to here. Want that from that direction. I think that specular highlight is just a little bit too bright, so let's take that right down. And the scale of the shadow, the depth of the shadow, I'm just going to bring that out a little bit, so a little bit softer. And then if I want further adjustments, I can come into the color page, and here I have the color intensity balance slider. So if I bring it right over here, I get much less color and more intensity. If I bring it over this side, I get more color and less intensity. So I'm going to bring that down, I don't know, about there maybe, and that looks pretty good. So that's our global imagery with the terrain drape. Now let's turn our drainage data back on. And now we can't see anything. So all those little tiny creeks are covering up our global imagery. We can't really see them. So what can we do about that? Well, the one thing we can do is transparency modulation or opacity modulation. In this system, we call it opacity. So I come up to the algorithm, and I've got to change the blending rule, and I'm going to turn on blending. Then I'm going to enable the opacity component for the drainage data. I'm going to choose the drainage data as the raster source. Come back into color page for this. Again, I'm going to want some nearest neighbor interpolation, same as the color. We had that on nearest neighbor. And we're going to have to give it a data transform. So let's go with a logarithmic transform. Okay, so we're seeing something already. So now we can still see the major river systems, but elsewhere we're seeing the imagery. And if you zoom right in, you can see that the major river systems are visible, and then they blend out. So let's come back out again. Just adjust this. So let's go to this. That gives us more transparency on the rivers. If we come down to say here, we're going to be seeing less transparency. I think we'll go about there maybe on our log scale. That doesn't look too bad. So that's an example of rendering the drainage data on top of our global imagery, which is draped on terrain. So we'll just look at the river channel width as well. So let's add a new lookup table algorithm. Again, we won't want any hill shading. Come into the color page and select the Merit Hydro width. We're going to want nearest neighbor interpolation again, and maybe we'll just stick it on equal area transform. So if we have a look at this data set just quickly, so here's the Amazon. Zoom in. See, it's only a pixel wide, but the river is 3.4 kilometers wide there. I think out towards the mouth it gets more like 6 kilometers wide. And some funny effects in some of this data. I mean, here the Great Lakes, which are registered as very wide. But that's the river width data. You notice that there's less river width data than there was river channel area. Next one is the hand data, the height above nearest drainage. So let's take a look at that. We'll just do a new lookup table algorithm. Again, no intensity. Come into the color, choose hand. Not going to do any interpolation. Now this data, so let's just go into sum equal area transform. So this data is continuous. There's data everywhere. And if you look at the values, you know, they can be quite significant. Like here, we're 225 meters above the nearest drainage channel. So if you're looking at flooding, for example, you're probably not interested in that. You're interested in the data that's within the maximum flood level of the channel, because that's the area that's at risk. So let's just go into here with our transform, maybe just change it to linear, but I'm going to use a manual clip, and I'm going to go from, say, 0 to 20 meters, which for a lot of things is probably well above the maximum flood level. And then I'm just going to clip above that maximum value, so above 20. So then all that red disappears and it becomes blank. So that sort of wipes out a lot of the data that we're not interested in seeing. And then you can start to see where there's data left. These are the areas that are more flood prone. So here's the Hawkesbury Nepean river system that's flooding as we speak. And if you go further up the coast in New South Wales, here's the sort of Northern Rivers area, and you can see why they're flood prone. There's all this low-lying land which is not very high above the nearest drainage channel. So they were the three data sets. Now let's put them all together and take a look at some specific examples that are relevant to the flooding in Australia today.